Hey guys, it's Mr. Wiegand. Today we're going to look at volume of prisms. And this is going to be part one of a two-part video series. My volume is the amount of space an object occupies measured in 3 dimensions. So we have here a cereal box, and it's got a length, a width, and a height. It's 3-dimensional. So volume would be the amount of space it occupies. Or another way to think of it is how much cereal could I fit inside that box and fill it up. That would also be that same amount of space. Same idea over here. I could take a ream of paper and I want to find out how many reams of paper fit into this box, and that would be a volume situation. Alright, so we have several or a couple volume formulas. If we have a rectangular prism, we have a length, a width, and a height. So our formula is volume equals length times width times height. Very easy. Just multiply those 3 dimensions together. If we have a triangular prism or any kind of polygonal prism like a pentagonal prism, hexagonal prism, anything that's not a triangular or rectangular prism, we're going to use this formula right here. Volume equals capital B, which is the area of the base, times the width. So the area of the base in a triangular prism, the base is a triangle, so we would find the area of that triangle. In a polygonal prism, it would be the area of that pentagon or the area of that hexagon. And then the width is the distance between the two bases. Okay, some people call that the height. Our formula sheet calls it width. Alright, so let's find volume of this rectangular prism. Alright, so this is going to be my length down here. That's my width, and that's going to be my height. So I'm going to use that volume formula. Length is 6, times width is 4, times height is 5. Simply multiply those all together, and I get 120. And we know since it's 3-dimensional, our label would be centimeters cubed, or to the 3rd power. When we did surface area problems and area problems, it was always to the 2nd power. They were 2-dimensional. Now 3-dimensional to the 3rd power. Alright, here's triangular prism. Okay, remember we're using volume equals area of the base times the width. So for this one, we have to first find the area of the base. So for the area of a triangle, it's 1/2 times the base of the triangle, little b. So the base of this triangle is 8 times h, the height of the triangle, and that's right here, 3. Alright, so 1/2 times 8 times 3 gives us the area of that triangular base. And then we're multiplying that by the width. And the width is the distance from one triangle to the other triangle. And that's the 10 right there. Alright, 1/2 times 8 times 3 is 12. And then 12 times 10 is 120. And once again, we're talking about volume. So centimeters to the 3rd power. Alright, now we're going to look at a pentagonal prism, and we have that formula, volume equals area of the base times width. And we don't actually have a formula that we use for finding area of pentagons or hexagons or octagons. So for these kinds of problems, I mean, there is a formula. We don't use it right now. So for these kinds of problems, we give you the area of the base. So the area of the base, capital B, is 12 in this example. And then the width, don't forget, it's the distance from one pentagon to the other. It's this right here. So this number doesn't have anything to do with the volume formula. So 5. And then 12 times 5 is 60. Volume equals 60, and it was meters to the 3rd power. Alright, so there's an example of a rectangular prism, triangular prism, and a pentagonal prism. I'm going to now give you 3 problems. You can do these on your own. So I would pause the video here. You do the problem, play it back, watch me do it, and then do the same thing for the next problem. Pause it, you do it, play it, watch me do it, and we'll see if we come up with the same answers. Alright, so this would be where you would stop the video here. Alright, so volume, we know, is length times width times height for a rectangular prism. That's our length, that's our width, that's our height. I'm always writing that formula and then substituting numbers in. That's a good habit. So my length is 10, my width is 5, my height is 7, and then 10 times 5 times 7 is 350, So my volume is 350 centimeters to the third power, or centimeters cubed. Alright, this is where you want to pause the video, and then you do it, and then come back and watch me. Alright, so this is a triangular prism. Formula is volume equals area of the base times the width. So the base is a triangle. And remember, triangle area formula is 1/2 times the base of the triangle, little b, and there's the base of the triangle, 4, times the height of the triangle, right there is 3. And then we multiply that by the width, the distance from one triangle to the other triangle, and that's this distance right here, so that's 8. 1/2 times 4 times 3 is 6. 6 times 8 is 48. Therefore, my volume is 48 inches cubed. Alright, last one. Pause it here. You try it, play it, come on back, see if we get the same answer. So volume equals area of the base, big B, times the width. Okay, remember for these, we give you the area of the base. It's right there, 20. The width is the distance from one of these hexagons to the other. That's this distance right here. That's 8. And 20 times 8 is 160. So my volume is 160 inches to the third power. Alright, there's volume part 1. There'll be a second video for volume part 2, and that involves when you're given the volume, maybe finding, the width, or finding a length of a rectangular prism, something like that, or trying some word problems. Good luck, guys.